And here, dear students, is an activity including several arcs of different measurements in radians, and we are going to plot the endpoints of the following arcs. And by the end of this activity, after recognizing what's going to happen, we are going to discover a new idea related to angles. Here are the circles. On each circle we have the endpoint of the arc given. Okay, so for example, arc AB measures pi over 3, which is corresponding to 60 degrees. As you know, we can simply replace pi by 180 divided by 3 to get 60. Here is the second circle corresponding to arc AC, which is equal to pi over 3 plus 2 pi, which is actually equals to 7 pi over 3. But notice that pi over 3 that corresponds to arc AB and 7 pi over 3 that corresponds to arc AC have the same endpoint, as you see here. And they measure the same amount, the same value in degrees, 60 degrees. Similarly for AD, which is pi over 3 plus 4 pi, which is when making same denominator 13 pi over 3. Here is D again. It measures 60 also. AE, the same. AF, and similarly for AG. So, what does that mean? First of all, notice that AB is just pi over 3. AC is pi over 3 plus 2 pi. What does 2 pi mean? What does 2 pi represent? As if I'm moving, let's read it like that way. 2 pi plus pi over 3. So how to move 2 pi? I start from this point. I make a complete turn till I reach here. Here is 2 pi. So 0 is the starting point till 2 pi, which is corresponding to 360. So actually 0 and 2 pi appear to be in the same place. Then 2 pi is gonna be equivalent to 0, and what remains is only pi over 3, which is equivalent to 60 degrees. So 7 pi over 3 is, to plot 7 pi over 3 is as if plotting just pi over 3. Now let's see for arc AD. Arc AD is pi over 3 plus 4 pi. Let's see what does 4 pi mean. Here is 2 pi. So here is 2 pi, the first turn. Now if I make a second turn, here is 4 pi. So 4 pi is coincident with 2 pi, is coincident with 0. So every time I move an even number times pi, I'm going back to 0. Similarly here, 6 pi as if I moved one turn, then a second turn, then a third turn. So 6 pi is actually 3 into 2 pi, and each 2 pi represents a complete turn. Then every time I have an even number multiplied by pi, that means that it is a multiple of 2 pi. And since 2 pi is coincident with 0 because it's 360, it's corresponding to 360, then every time I have a multiple of 2 pi, 4 pi, 6 pi, even in negative, because this even number multiplied by pi is equivalent to 0, and what remains only is this value, pi over 3. Now how to move minus 2 pi? Similarly, we move it like this. In the negative sense, here is minus 2 pi. So again, I'm still at 0. So to sum up, whenever I see an even number multiplied by pi, I can cancel it because it's somehow coincident with 0, and what remains is the value that I care about. Now this value is called the principal value indeed. Now let's learn more about the principal value. What we notice using the previous example, that all of these arcs have the same endpoint, so that means there are infinite number of angles having the same endpoint, because every time I add a multiple of 2 pi I will get a new angle, but they all have the same endpoint. But there is one and only one that belongs to the interval minus pi pi, which is actually pi over 3. It is between minus 180 and 180. So there is only one value that belongs to this interval, and this value is called the principal value of angles.